Good morning, fancy meat computers. How's everybody doing today? Incidentally, it's an Earthbound reference. It's an Earthbound reference. Nothing like a good cup of tea in the morning. Yes, good. Hello. I don't think, don't you ever wonder why you're from? Yes. Anyway. Enough silliness. So. I don't think we have any, pressing, announcements or anything. It's kind of just like the course as usual. I forget if I announced, A1 being posted, but that was posted on Monday, so obviously I would have mentioned it in class if I hadn't already. Assignment 1 has been posted. A lot of people have been, like, doing the GitHub thing, setting that up. I've been getting a lot of emails. About that, so, yeah. Anyway. So we might as well just press on. We've got so much time and so little to do. Strike that. Reverse it. Alright, come on. Let's do this. So, we were talking about operators and your range of available operators. So, last time I did this class, I thought that bitwise was something that you guys will have heard of before, but I don't think that it is something that you guys will have heard of before. Have you guys heard of bitwise operators before? Quick question. Actually, I should do a poll. Have you heard of bitwise? Yes or no? Ask. Yeah, it's... Well, don't worry. The assignments will get harder. A1 is just like... Okay, have you acquired, like, a minimum level of competency to be able to write a C program? So, like, 1 or 2 people out of all of these people know what bitwise is. Okay, well, bitwise. So, bitwise operators are operations that occur on the bits themselves. We have a segment coming up in much later in the course, actually, when we're going to go through bitwise in somewhat more detail. A good way to think about it is Boolean logical operations as applied to the individual bits in a number, right? So we have 6 of these operations, which are typical, and we're going to go through how they work. You may ask yourself, why? Why do I need all of this? When you get into your embedded systems courses in 3rd year, it's going to be useful to know something about bitwise operations because, there will be functions that you can, when you're writing to the pins of a microcontroller or something, setting voltages high and low and that sort of thing, having bitwise operations available is a very useful thing to be able to do because you'll be operating primarily in individual bits. And when you're operating in individual bits, it's useful to have operators that are designed for that. So, here we go. Okay, I have a question. Can you get test cases and their expected results for assignment 1? Do you need them? For assignment 1? I thought it was so simple you wouldn't need them. Send me an email about it. I'll see if we can pull something together for you guys. So, yes. So, this is, if you're unfamiliar with this term, with this form, this is called a truth table. So, if we have x defined as 11110000, and y defined as 11001100. This is how it works. All right. So it's the rendering didn't come through. So this is the first one. This is not, right? 1's complement, which is the same thing as not. So that just takes every bit in x and it inverts it. So every 1 becomes a 0, and every 0 becomes a 1. Plain and simple. Oh, I wouldn't just send test cases to one student. That's like... What kind of cruelty would that be? So, next we're going to talk about left shift, right shift. So, generally speaking, when you're talking about numbers, when you're talking about binary representations of numbers, we usually arrange them the same way that we arrange decimal numbers, with the big stuff in front and the small stuff in the end. This is a format for storing numbers, which is called Big Endian, which is actually a reference to Gulliver's Travels by Jonathan Swift, where Gulliver travels to an island, a couple of islands with people who are only that high, and they're having a war with each other. You have the Big Endians versus the Little Endians. The Big Endians believe, with religious conviction, that the correct way to crack an egg is starting with the big end. And the Little Endians believe that, with religious conviction, that the little end of an egg is how it is correct to crack open an egg. So that's where the term Big Endian and Little Endian derive from, and most systems you'll find these days are Big Endian. So when you have shifting operations, left shift is functionally equivalent to multiplication by 2 to the power of however many bits you're shifting by. In tactile forms, you take this number, you shift it left by however many bits is indicated, and you backfill with zeros. So these 2 bits are lost because they are shifted past the end of the integer, and these guys go here, these guys go here, and then 2 zeros are added. Right shift is exactly the same, but in the opposite direction. Right shift shifts you down. It's equivalent to division by 2 to the power of however many bits you're shifting by with truncation. So if you have a 1, just like 1 bits here would be lost, any bits that are here, that information is also lost. You're shifting down. That's right shift. What inverts the bits? No, it's tilde character. The rendering on this slide didn't come through. It's a tilde character. Aren't the test cases in leap years just checking if it's a leap year on Google? You don't even have to check if it's a leap year on Google. It's every year that has the Summer Olympics in it is a leap year. Every year that's divisible by 4 is a leap year. Yeah. Is there a reason why there is 8 bits and not 4 in the example here? Just because 8 bits is the smallest thing that you're going to operate on is 8 bits. So, yeah, your colleague, I could blow out every other column and it would still make the same amount of sense. So, next we have bitwise AND operation. So, up to now we've 1's complement is a unary operation. Left-right shift is a binary operation, but you don't really care about the bit encoding of the second argument. You just care about its raw value. With the bitwise AND operation, you are performing logical AND on the individual bits that comprise the number. So if we have x and y, 1 and 1 is 1, 1 and 1 is 1, 1 and 0 is 0, 0 and 1 is 0, and 0 and 0 is 0. So you get 1, 1, 0, 0, 0, 0, 0, 0. Similarly, bitwise OR, which is a single bar character, that performs the same type of operation as the logical OR operator, again affecting only the bits. So where either of these bits is 1, you'll get a 1 here, and only a 0 if both are 0. And XOR. So the reason you may not have heard about It's not a leap year if it's divisible by 100, but not 400. Are we checking that case? Possibly. I'd have to check. I'd have to check to see if we're checking that. So, XOR. XOR is an interesting one. The only, it doesn't really serve much purpose logically. You can compose an XOR operation reasonably easily from an AND and an OR operation. It's just, X or Y subtract X and Y. But it comes up a little more frequently when you're doing bit bashing operations. XOR stands for exclusive OR, and it's an OR operation that's exclusive of AND operations. So it only returns 1 when the two inputs are different. When they're the same, it returns 0. This is often used for bit masking or bit flipping operations. The AND operation is used for bit masking, and the XOR operation is used for toggling primarily. So if you want to blink an LED, for example, the easiest thing is to just use an XOR operation on that at regular intervals. Yeah. So XOR only turns on if X does not equal Y. That's correct. If X and Y are exactly the same, then XOR will return 0 because it requires difference in order for it to return anything. Yep. So that's bitwise. Let's move along to relational operators. Yeah, actually, that's a really good example. So Avery brings up, the only logical application I can think of for XOR is a light that's controlled by 2 switches. For example, if the switches are in different positions, the light is on, and if they're in the same position, the light is off. So that would be a 3-way switch. So you know how you have, sometimes you'll have a 3-way switch at, either end of your living room in a house? That's how you got, yeah. That's a good one. I'll remember that one for future lectures. Thank you, Avery. So XOR is an OR operator that excludes true cases. Yeah, it's an XOR operator that excludes the case where both are true. Yes. So let's talk about relational operators, or comparators. So we've got equality. Equality functions in exactly the same way that you would expect it from Python. Inequality, it depends on how you do it in Python. I believe exclamation point equals is valid syntax in Python, but I think it's more common for people to use the not keyword. The not keyword is not a keyword in C, so in order to do an inequality, you have to do bang equals. I'm going to call this bang because that's shorter. Greater than, how you expect, greater than or equal to, all of these guys are how you would expect in Python. And you have your logical operators. So logical operators are slightly different. In Python, they expect you to use actual English words, not, and or. In C, as with most languages, you have special syntax for it. Not is you have a prefix bang operator, that's logical not. And is 2 ampersands, and or is 2 vertical bar characters. Note the correspondence between the bitwise and or, and the logical and or. The number of symbols used should tell you which of these preceded the other in the history of the development of operators in computer languages. So, for your next assignment, so you may have seen a few of these. You're likely to have seen plus and minus equals in Python, but in C, you can actually perform like most of your arithmetic and bitwise operations with assignment bundled in. If you do like plus equals, minus equals, times equals, divide equals, modulo equals, left shift equals, right shift equals, and equals, or equals, and XOR equals. You have all of these different assignment operators available to you. This is not, all of these operate in the same way that you would expect plus equals to. Just swap the operator out for something else. So there you go. So here are your keywords in C. They are... Can't you do that in Python too? Probably, but, you probably haven't seen the full list, right? It's possible that a certain amount of this will cross-pollinate back into Python. Hopefully, learning C will make you a better Python programmer. But if you can, you can. That's great. If you didn't know about it before, now you do. I should end that poll. Let's see here. Boop. There we go. So, the keywords of C are as follows: auto, do, go to, sign, unsigned, break, double, if, size of, void, case, else, int, static, volatile, char, enum, long, struct, while, const, extern, register, switch, continue, float, return, type def, default, for, short, and union. And over the course of this course, we're going to teach you what most of those mean. I don't think we ever get into what volatile means. I'm not sure what volatile means. Keywords added in C99, bool, complex, imaginary, inline, and restrict. And in C11, align as, align of, atomic, generic, no return, a static assert, and thread local. If C is so good, why haven't they made C2? What do you think C++ is? So, if statements. We'll talk about branching. So, if statements are a little bit different in C versus Python. So, in Python, the regular C if statement is, the primary difference is that you're using curly braces instead of indentation. Again, indentation doesn't matter in C. You can write your entire thing on one line if you want to, and that's fine. We spent $500 million on a useless election. That's a lot of money to spend on an election, but not a lot of money relative to the rest of the money that the government has been throwing around these days. So, you got to keep perspective. 500 million is not a great proportion of the, 300 billion that they've been spending. But anyway, what is an application of shifting? Okay. Good question. What's an application of shifting? It's a division operation that is much, much faster than the regular division operation and multiplication operation. So if you're multiplying or dividing by 2, it's actually significantly faster in terms of, like, the amount of time a single command takes in your CPU. It's much faster to do a shift operation than it is to do a proper division or a multiplication operation. Because there's a lot of baggage that comes with those operations. And if you're just, multiplying by 2, it's essentially taking advantage of the fact that the machine is binary to do your multiplication for you. So that's one application. You can speed stuff up with it. Another application that you would see sometimes with these bitwise operations in general is a something called a checksum. So one of the ways that you would verify data integrity over something like a network, and I'm not even necessarily talking about the internet here. I could be talking about communication networks between different ICs on a circuit board. You could, for example, I squared C or I2C communication. You can build in what's called a checksum. So the idea of a checksum is you take every data packet that passes through the communications network and you perform XOR on it or something like that, and then at the end you'll have a unique number that can only be reproduced if none of the packets were corrupted during transmission, so long as the checksum itself wasn't corrupted. So you can send the checksum at the end to say, okay, if you perform XOR over all of these operations, you should get this number at the end. And if you don't, then the data was interfered with in some way. And so, it's typical to use bitwise operations for this type of thing instead of, some arithmetic operations, because bitwise operations are very fast, and typically when you're talking about network applications, speed actually does matter. So, yeah, shifting only applies to powers of 2 because that's the binary system itself only operates in powers of 2. So yeah. So that's an interesting application for you, of bitwise in general. Shifting in particular, it doesn't come up very often. That's the thing about these bitwise operations. It's you should know them. They're not going to come up very often. I would be surprised if you had to do bitwise operations more than a dozen times during your entire degree program for various assignments. But, it's still a very useful tool in your toolbox. So anyway, in Python, you have an elif. In C, that's replaced with else if. There's no elif keyboard. You have to separate it out. And that otherwise, if statements are exactly the same. Writing a program to check if something is a power of 2. It's difficult to know if it's through decimal numbers, but in bits of all power 2. Yeah. Yeah, there are certain types of mathematical problems that you can only solve with bitwise. They're very different operators, and they do interesting things. Basically, the further you get into optimizing things, the more likely it is that you're going to end up doing something with bitwise. So there you go. How do you run a console command through C? I'm sure there's I'm sure there's a function for it, but we'll see if that comes up later. Let's keep. I want to finish this today. So Mom, can we get an if statement? No, we have an if statement at home. The if statement at home. While condition statement 1 break. While not condition statement 2 break. That's just a joke. So, let's switch just in case. So, switch cases are something that you're still confused by the placement of the curly braces. Okay, well, that's an important thing to go over. So, the curly braces indicate that the statements are inside of this if branch, right? So, curly braces are literally the same thing. The literal Python equivalent is tab level, right? So, when you open up curly braces, you'll notice that everything within the curly brace is tabbed over one level. This has been a programming standard for a very long time, and in Python, they made that into the actual semantic of the language, that you needed to include the correct tab level. But in C, you don't have to include the tab level. It's indicated by the curly braces themselves. So there you go. Using while loops as if statements genuinely triggered me. Yes. Good. That means you're a real programmer. So let's talk switch statements. So the way if statements were designed for Python, they were essentially made using that same while loop format. Ha! No. So, Python doesn't have switch statements. I think that there was talk about them including switch statements. So I haven't checked the latest release, so maybe they've included switch statements. But their explanation for why they didn't include switch statements way back when they were designing the language was, well, an elif can do that, so why do we need a switch statement too? You know, the Python design philosophy was there should only be one way of doing something, which is stupid. It's a stupid philosophy because it makes, honestly, the lack of switch statements in Python, for me, for anyone who's experienced with programming any language other than Python, programming in Python is like getting constantly poked in the face by a pedantic asshole. And this is one of the reasons. Because literally every language has switch statements except for Python. Anyway, so this is what a switch statement does. You provide a variable or an expression or something that evaluates to something. And you have a bunch of cases. Depending on what case this guy evaluates to, you begin execution at that label, right? So this is kind of a form of contained goto. But yeah. So if x evaluates to 1, then this statement would execute. If it evaluates to 2, and there's no break statement, then it would execute everything in here and everything in here, and then it would break out. And default is if none of these other guys were hit. So this is more compact notation than you would get with else ifs, where you would have to be repeating the equality comparison every time. So, what is a switch statement? Well, it might be best to show you by example, actually. We have a few. I have an actual example of a switch statement. So, let's switch just in case. In this example, x is the controlling expression. The value of the controlling expression is compared to each case label, which is a literal of the return type of the controlling expression. So, controlling expression, label, case label, right? So execution jumps to the corresponding case and exits the switch block when it hits a break statement. This means that execution may pass through multiple cases before exiting the switch block. Default function, the default tag, functions like the terminating else in an if-else chain. If no case matches the value of the controlling expression, execution jumps to the default case. Why the break statements would matter in a case that isn't being evaluated. Well, it has to be there in case it is evaluated, right? You have to include break statements. So anyway, I'll show you. Here's an example. This is an example. This is a little program I wrote at one time called Sarcastic Grades. Sarcasticgrades.c. Do I have sarcasticgrades.c, or is it like, did it not make it into the repo? It might not have made it into the repo. Shucks. Okay. Get it. Sarcasticgrades.c. So, can I copy paste? Oh, that's gonna be horrible. It'll be faster to just type it. So, include stdio.h int main void. Still getting used to this keyboard. So, char grade printf. Enter your grade. Scanf. Type character. Store it in grade. So this is an example of using just a character without using a string. Switch. Grade. Switch block established. Case 1. A. This is also character practice for you guys. Printf. Amazing. A smart person. Case. B. Printf. You have met expectations. Case. No, break. Break. There we go. Case C. Printf. You need to study harder. Case D. Printf. At least you passed. Break. Case F. Printf. Well, they're always hiring in the army. And I forgot terminal new lines everywhere. Boop, 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 boop. Another thing that's amazing about Linux, in case you needed more reasons Linux was amazing, if you highlight something and then click with the middle mouse wheel button, that's like a copy-paste where you don't actually have to hit copy-paste. And then default, that's a break there. Printf, that's not even a proper grade. There we go. So, let's see if I wrote this let's see how well I wrote this. GCC, sarcasticgrades.c. Error. Ah, shoot. All right. I've got a lot of questions. All right, let's see here. Why would you use a switch statement instead of an if statement or something else? Because it's faster. It makes, like, it minimizes redundant typing. But it does, like, slightly different things because you can have, like, execution fall through them. Okay, let's see here. I'm missing a terminating semicolon. Break. There we go. A dot out, which is the default. Enter my grade. A. Amazing, a smart person. You have met expectations. Enter your grade. B. You have met expectations. Enter your grade. C. You need to study harder. At least you passed. Enter your grade. D. At least you passed. At this point, we're giving up hope. Enter your grade. F. Well, they're always hiring in the army. G. That's not even a proper grade. There you go. So that's how it works. I will now answer questions. Why is there a break after case D and B and D, not A and C? Because I want if you enter A, I want to print both of these things, and I want to also print this in the case of B. Why have you set it up where I would rather hear the D grade response as opposed to the C grade one? Because people who get Ds are more in need of, like, if you're C, then you're, like, borderline B student, right? So if you pull up your socks, you know, you could hypothetically achieve meeting expectations, but it's a much harder climb for D, you know? Microsoft Word is best IDE. Yeah, no, it isn't. No, it isn't. Microsoft Word is not even the world's best document processing system. That crown belongs to LaTeX, my friends. Plain text for everything. Why do we... Yep. Hypothetically, if we wanted to, could we put the case and statement on the same line? Yeah, I think that works. I'm pretty sure that would work. Normally, new lines don't really matter. Yep, yep. Stylistically, you can put these on the same line if you like. Absolutely. Is default like an else statement? Yes. Funny computer man makes a mean program that makes me feel bad about my grade. Yeah, that's, I mean, yeah, it's, the program is called Sarcastic Grades. Why did it include the B case for an entry of A? Because there's no break statement. This example is, like, that means that I formulated the example correctly to show you what I wanted to show you. Unless you put a break statement in, the case will fall through, like, execution will fall through the A case into the B case. It'll keep going until it hits a break statement. That's what I wanted to show you with this. What text editor am I using? Get it. GNU Edit. It's like the Notepad equivalent of... It's like Notepad, but for Linux, except it also does syntax highlighting. And it auto-detects what syntax you have based on the file extension. Yeah. Until it hits a break. Yeah. Actually, once it hits a break, it jumps all the way down to here. And then it's done. So semicolons are what tells the program that... are what tell the program that what follows is a new line. Yes! 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 That's what a new line... That's what a semicolon does. It's a line separator. It's a line separating character. It's a statement separating character. Basically, if you take your understanding of it and just, like, disassociate statements with new lines, you're 100% correct. A statement doesn't have to occur on a new line. It just does in Python. Is this more of a general question? But whenever I try to print a variable, I get this warning: format not a string literal, and no format arguments. Check to make sure you're using double quotes, not single quotes. So, there we go, cue demonstration. So, I got 10 minutes, so let's talk about the forbidden magic. Let's talk about the forbidden magic. We're going to learn the dark arts, by which I mean defense against the dark arts. So, a historical note on goto statements. You know, I referred to switch statements as being kind of like a contained form of goto. At one point, there was no such thing as an if statement, or a while loop, or a for loop, or any of that junk. Program execution was controlled exclusively by one statement: goto. A goto statement changes the value of the program pointer to some other spot in the code. So the program pointer, with every program that runs, you have the code for the program listed out in your memory, and the CPU keeps track of where you are in the code. It keeps track of what statement you're on, right? This is called the program pointer. It points to where you are in the program, hence program pointer. It's internal to the CPU, but this is what you're doing when you write an if statement. You're writing things that manipulate the state of the program pointer. That's what control flow means. It means manipulating the state of the program pointer. So, a goto statement is the most direct manipulation of the program pointer, because it just says go to here, and it's like, okay, boop, and it does. So in BASIC, not Visual Basic, but BASIC, this was done with using line numbers, and the line numbers had to be your lines had to be numbered manually. So in the very old programming language BASIC, you actually had to number your lines yourself. This, in general, made code just about impossible to read, and originates the pejorative term spaghetti code. So the problem with goto statements is that if you have a lot of goto statements and a complex program, it becomes impossible to follow any thread of logic through the program by reading it. It's kind of funny that, like, there are apocryphal stories about programmers in the 70s and 80s who write programs that are literally undiscernible to anybody else but themselves, and thereby, you know, like they tend to be nasty people, and when they get fired, their projects have to be completely restarted because nobody can possibly work with the code that they've written because it's so convoluted. So, generally speaking, this is why goto statements are persona non grata. If statements and while loops are syntactic sugar for specific goto structures. Technically, modern control flow is less flexible, but much more easy to use and reuse and read. So when we get into assembly programming at the end of this course, the only kind of control flow that you will have is goto. So that's why we're bringing it up now. C, you may be surprised to learn, has goto statements and still supports them. You can write goto statements right now in C code that you write, but their use is strongly discouraged. It is discouraged in the strongest possible terms. I will flunk you. I don't care. I will bring up a vexatious and malicious and false charge of academic dishonesty against anyone who uses a goto statement. They can't fire you if you're the only one who knows how the code works. They can, actually, because it could be cheaper to just replace you and redo the project. Yeah. So, oh my goodness. There we go. So, here is the forbidden knowledge. I am about to teach you the forbidden knowledge, because in this class, we don't shy away from the dark arts. This is how it works. Okay, to use goto statements, which you should never ever do for any reason or I'll flunk you, do the following. First, create labels within your program. A label is any identifier followed by a colon, so very similar to like the way that Python indicates if statements. And then create goto statements referencing the labels. So, for example, speak not its name lest ye go mad. This program implements a do-while loop using goto. So, main int n equals 1. You put a label in there. You then have printf and n++. Then, I could have done the if statement with gotos as well, but if n is less than 10, go to label. So, it's checking this case. If the case comes out like if n is less than 10, then you head back to the label. The program starts back up the label and then continues going. So here's some nasty little things about gotos. They can jump you to inside of functions. Just let that one sink in a little bit. Yeah, you're going to have to go to the Academic Dishonesty Office if you use gotos. Yeah, okay. People are talking about other stuff in the chat. So, yes. So that's a goto. So let's talk about loops, because we've got 5 minutes, which is enough time to go through loops. So, in C, there are 3 types of loop, which are actually just one type of loop, with different flavors. So, you've got whiles, do-whiles, and, for loops. So, there are also 2 control statements for use in loops, break and continue. So, while loops work in C the same way as Python. A while loop is a while loop in any language. Do-whiles, however, are a slight variation. With a do-while loop, you do the stuff in the loop first, and you check the condition at the end, right? In a regular while loop, you check the condition up front, and then you see if you're executing the stuff inside. Whereas with a do-while loop, you do the stuff first, and then you check the condition. So it's kind of like a lazy check, because this is a procrastination loop. I think we'll talk, because it's checking the condition at the last possible time. So, while loops test... Yeah. Yep. This means that a do-while loop must execute at least one loop iteration. So, when you're writing a loop, and it needs to execute at least one loop iteration, a do-while loop is what you want. Aside from that, there is no semantic difference between while and do-while loops. Generally speaking, do-while loops are like one of those old things that nobody really uses anymore, but it's in there primarily for legacy purposes. Although it's useful, most people are like, well, I could just write a while loop that does the same thing. Why do we need 2 of these? It's kind of similar to the else-if switch case argument, except this is an even more slight variation. Like, is actually a purpose to switches. So if you use goto to jump in a previous spot in your code, it would go run the goto you just used earlier in the code over and over and over again. Yes, until the if statement comes out false, in which case it would skip this statement and just return 0. Yeah. So, formidable coding. In Python, a for loop is used to iterate over the elements of a data structure. Lists, dictionaries, sets, tuples, strings, etc., etc., etc. In C, for loops are just syntactic sugar for the most common while loop structure. For loops and while loops are the same kind of loop. You notice with the while loop that you have outside the loop you have an initializer, you have an update statement inside of it, and then you have a condition. The for loop, all it does is it collects the initializer, the condition, and the update statements into one line. That's all it does. For example, printf t minus for int I equals 10, I is greater than 0, I minus minus. You count them then down, and then you go blast off. So that's a for loop. It's just a while loop. They're still recommended over So for loops are still recommended over while loops because they're not syntactically correct unless you have provided the initializer, the condition, and the update function. So if you're using a loop of that structure, then this is it's good to use a for loop because you'll, hopefully not forget to include the update statement, which is the most common cause of infinite loops. But yeah. So continue and break for lunch. Two statements may be used to control loop execution outside of the loop's main conditional. 1. Break exits the loop. When the program pointer hits a break statement, the top-level loop of the program that is iterating is immediately terminated. So if you're in multiple loops, it's only the loop that you're currently in that gets broken. And so it's immediately terminated as if the condition came out false. Break can be very useful for programs with complex logic. The truth literal can even be used as the loop conditional if the program breaks correctly. So, you can set up an infinite loop so long as you're breaking it at the appropriate time. It's kind of like doing a more complicated type of exit condition. And you may have noticed break is also used in switch case blocks. Continue starts the next iteration. So it jumps immediately to the next iteration of the loop. The applications are not as numerous. Most people use if branching to not execute the rest of the code inside of a loop, rather than use a continue statement, but continue can reduce the level of indentation of your code. If you're at like 7 or 8 indentation levels, you can knock maybe a couple of them off by using continues instead of if guarding the rest of your loop. So there you go. Last slide comic. I could restructure the program's flow, or use one little goto instead. Screw good practice. How bad could it be? Compile. And then he gets attacked by a raptor. Let that be a lesson to you. If you use goto statements, you will be attacked by raptors. So I'm gonna clean up some of these questions. So continue is like pass in Python. No, pass is like a skip statement, I think. Maybe? I might be getting that wrong. I don't know. I forget if pass... I'm pretty sure that Python would have a continue, actually. Let me look that up quickly. Python continue statement. Yeah, no, Python totally does have continue. Python totally has continue. Pass does something else. Pass is what you provide if you want it to be syntactically correct, but you don't want to actually put a statement in there. All right. So. Yes. Yeah, you can't use logical statements inside of switch blocks. So going back to switches for a moment. So this is really, the replacement for this is a sequence of equality comparisons. If you're comparing for ranges, then if statements are still preferred, because you can't do like 3 is less than, like x is less than 7 inside of these. These are only equality comparisons. Okay? Good thing they're extinct. What's the worst that can happen? Are you sure they're extinct? Have you been to every corner of the world? Do you know that dinosaurs are extinct? Have you seen every corner of the planet? Have you plumbed the depths of every deepest lake on the planet? Do you know that there aren't any plesiosaurs hiding in lakes in Scotland? Tell me. Python has both continue and pass, but the difference has never been understood. Yes, they're starting to reanimate woolly mammoths, so there you go. Reanimate. Yeah. Try a go-to statement to find out, yeah. Yeah. Okay. So I think that's a good class. I think we did good this class. So, not to mention, did we just finish topic 2 like perfectly on like our last class of this week? Because if so, I'm pretty impressed with myself. Yeah. So, what's our next topic then? Next time we will be doing functions and recursion. There's a picture of pancakes in this one. It's going to be a lot of fun. It's going to be a lot on functions and a little bit on recursion. You guys should know recursion. Recursion is super useful. It's super important for like the comp sci guys. Like, if you can't think exclusively in recursion, then you're going to have problems in third year. Not so much for you guys, but it's still a very useful mathematical tool, so we're going to go over it. But, yeah! Dinosaurs are not extinct. You should have seen your high school vice principal. The dinosaur of the gaps argument. Yes, that's true. With that logic, did the moon landing ever happen? Yeah. You can... yeah. Guess why there are pancakes. Recursion is not evil. Recursion is the beautiful music of the universe. Trees are recursive because fractals are recursive. So, this is how I'm going to explain recursion to you guys. Fractals, right? Fractals are cool and interesting. Like, when the sub-diagram is the larger diagram, just smaller and inside of the larger diagram. That's what recursion is. It's just fractals. It's fractals, but with math. And fractals are already math, so there you go. Yeah. Cool. Anyway, take her easy, folks. I'm going to be doing office hours this afternoon, so if anybody wants to drop by 102, I'll be there. If in doubt, pseudocode it out. Ha! That's a good one. I have one that I put on assignment 1, which I like. It's about repositories. Failure to commit is commitment to failure. Cool. Anyway, take her easy, folks. I'll be seeing you next week, or possibly sooner. Take her easy.